Okay, guys, let me move forward and explain this character movement initialization here. So, we are using this. So, first of all, we are using this move move variable here, and this move variable is storing whatever this get character movement function is returning. So let's just check what it's returning. Going to the definition of the function, and you can see it's returning the character movement. And the character, what is the character movement is actually a movement component used for the movement logic in various movement mode, walking, falling, etc. Contain relevant setting and functions to control the movement. So basically a object, character moment of the character moment component, which is responsible, or which is storing the logics and the various moment modes of the of a character class. Okay, so that's why we are storing it in a pointer, and the class of the pointer is hue character moment component. And now we are using its properties to set up our default values for the character moment. So here you can see the orientation movement. I keep it false because I keep this B use control rotation yo to true. If I keep it false and keep it true, let's see how it reacts in Unreal Engine. So let me hit the build button here, and waiting to build to be complete. I think it's completed. Now the Unreal Engine is warming up, loading the shaders and everything, plugins. So it's warmed up. Let me hit compile. It's compiling. I'm waiting for the compile to be succeed. It's compiling. It's complaining about some memory. Looks like it's got succeed, and I can when hit and play. So now we're pressing W. C, I'm pressing S. So I while I keep this your rotation to false and this to be true. So what is happening here? Our capsule components, I mean the capsule component that we we set up at the first place, it has some arrow direction, and that arrow direction got you know um rotated when I without rotating the camera. So basically what's happening, the camera is staying in one place, and your capsule component is kind of rotating. So what is the capsule component? If I go to the blueprint class here, so this is the blueprint class that I have created from the C++ class, that I'll have a separate video for that, and how I've created this blueprint class, and how I set up all these you know these input classes here. Let me show you input actions here, with the blueprint class. So let's just go to this blueprint class at first. Okay, so this you can see this capsule component here. So this capsule component, it's got, it's rotating without, well the camera is fixed. Okay, so with these settings, and I don't want my character to be rotating without the camera being rotated, right? So that's why we should always keep it true, and this should be kept at false, as false. Okay, so now I'm setting up the rotation rate. Your rotation rate as like this. I mean, I'm setting up the um, F rotator and the your rotation to 500.f, and I don't want our character to rotate in P channel role, so I keep it 0 and 0. Then there's I'm setting up the jump velocity, air control, max walk speed, and the other stuff here. So these, if I go to the definition here, so these are also, tweakable from the blueprint. So these values I set up randomly. I'll tweak it if we don't if it doesn't match with the animation, or doesn't match with the situation, with the gameplay. Okay, so um, that is how we set up the initial character movement, and these are the main these are the some main components, which are the camera components. With the camera components, we have the one spring component and one camera component. So if we go to the blueprint class, you can see there are two camera component. One is camera boom here. So this is the spring arm component, and this is the camera component. So these two component that we had set it up with a C++ class, and I set up this spring arm component. I mean, attach this component to the root component, because I want the in that particular case, the root component is the capsule component here. So the you can see the hierarchy here. The capsule component is the root one, and this camera boom is means this spring arm component is attached to the capsule component, and the follow camera, this one is attached to the camera boom. So what it does mean is, it means I want my camera to be controlled with the spring arm component, and the spring arm component to follow the the controller. Controller means the keyboard or the joystick, whatever we are using to control the player. So that's how we set up the camera and the spring arm component here. So this is the begin play section. So I'm using the super. So this begin play is a function which is already being defined and declared in the a character class. The a character class is the parent class of the hero character CPP, or the hero character class. Uh, so what this particular super begin play means, it means whatever the function or whatever the functionalities we have already defined in the character class, that should be in line first, and then the override will happen. So in the over in this override section, what we are checking here, at first we're checking if we if we have the you know controller itself, and we are storing it as a in this variable, and this variable is a pointer, and the class of the pointer is the a player controller. So what it's checking here is first of all it's checking if there is any controller or not, and if there is a controller, is it controlled by the AI, or is it controlled by the AI or not. So that this is why we're using the cast here, okay, to to check the controller if it's, you know, practically present or not. So after that uh, we're storing the subsystem, and checking, I mean, and checking that we're using the you know enhanced input player system, right? So if the player controller itself, you know what this particular snippet is actually checking, is checking if the local player is possessing the or using the enhanced input local player subsystem or not. So if it's using the UI, I mean, if it's using the Unreal Engine enhanced input player system subsystem, then it will it will check our mapping context. So if I go to the content browser here, so in the input action, so you can see we have created this input mapping context where we have mapped our actions, input actions, like move, look, crouch, jump, sprint. So this is going to check at first, like if the macro is actually hooked up with this variable. So again, we have already discussed this variable is already being defined in the header file, and it's being editable from the blueprint. So if I go to the character blueprint class and search for the default uh, mapping context, okay, mapping context. So you can see this default mapping context. I set it up. I hooked up this hero input mapping context. Um, so it's basically in the CPP, it's checking if it's already being hooked up or not. If it's got hooked up, and then we are telling like our subsystem to add the mapping context as a default mapping context, and the zero means the I mean keep it as a default. I mean, I'm telling this subsystem to this is our object which we need to map and keep it as the default. So moving forward with the setup player input component function, this function is also being defined and declared in the a character class. So we are just using to override this to bind our input actions to our hero character class here. So first of all, we are checking if we are having the you know player component, and the type of the player component is a um, Unreal Engine enhanced input component or not. So if it's true, then I'm storing it. We are storing it in this variable, and then we are using this variable. We are binding the actions to the character class here. So here we are checking This is the jump action. So I've already discussed in the previous video that we have created this jump function as a you input action type. These the pointer type, and it's holding some object, and the object is this one. So if I go to the blueprint here, and if I type jump action, so you can see this jump action variable is being accessed from the blueprint, and we are hooking this input object to this jump action variable. So here in the CPP, we are checking if this object is there or not. So if it's there, then we are binding the action here. So for the jump action, we have two trigger event, one for the started and one for the completed. What does it mean? Because what does it mean is that suppose we are using the space bar for the jump action, right? So we are telling that bind the action. So what is the action? The action is jump action at what event? The trigger event would be started. What is the started? What is the started trigger event? Is suppose we are using the space bar, and we press the space bar to make the character jump. So in that particular point, that event got started, right? So when the event got started, we are saying that then whatever the functionalities we're having in the jump function here, you do exactly the same. So this jump function, why we are referenced from the a character class, not the a hero character class? Because the jump function is already defined and declared in the a character class. We don't need to separately define or declare anything or do anything with the jump function. So that's why we're just straightforward go ahead and using this inherit jump function here. So this next one, the completed one, is when we release our space bar or the key input. So in that particular time, that event got triggered, and was what it's telling to do. It's telling to do to stop jump to the hero character. So this stop jump is also inherit function that have been referenced from the a character class itself. So moving forward here, we are in the same way we check the jump action here. We are checking this move action. So if we go to the blueprint class here and check for the move action variable. So the move action variable is there accessible from the blueprint, and we are hooking this input action object to this variable. So likewise, the jump action, we are also binding the move action with the with our function which we have created, or we have declared in the CPP. Sorry, the define and declare in our hero character class. So if I go to the definition, so you can see this is the move function that that is being referring to on the move action trigger event in the yeah. Okay. Okay, same way, the look action with the look action trigger event, we are binding the look action, and also telling to do whatever the functionalities we have written in the look function here. In the same way, we have bind this sprint action, crouch action, and attack actions. So, okay, so moving forward with this function here. So going ahead, so the move function is actually have a parameter or argument called value, and its type is if input action type value. So suppose we press W, S, or A or D in a keyboard. So in that particular time we are passing some values, right? So those values being passed when the key being pressed or the event being triggered, and when this function being referenced, that value being passed into this into this function as well. So uh, suppose we press W in that particular scenario, probably will be receiving x equal to 0, y equal to 1, or on pressing S, hypothetically will be receiving x equal to 0, y equal to -1. Why -1? Because W is for the forward direction and S is for the backward direction. That's why with pressing S there should be always will be getting the -1. So these values are being passed to this function as a if input action value, and then we're storing the 2D vector values like 0 and 1, those values into this variable. And then we're checking this controller. If the controller is a null pointer, then it should return. Moving forward to these code snippets here. So you can see we have already created a f rotator variable yaw rotation, called yaw rotation, and it's storing the controller yaw rotation inside it. And we also have these two f vectors. So one is for the forward direction and one is for the right direction. It's acting the opposite. Suppose we're pressing D, so at that point of time the x should be 1 plus 1, so the right direction into 1, so it will be going to the right direction. I mean the taking the right step, and if we press A, then the right direction, and then this x value would be -1. So with multiplication of the right direction, so that means it is going to the left direction, because we are multiplying with -1. Same goes here as well. um, then with the forward direction value, it will be multiplied. The y value will be multiplied. Suppose we press W, it will go to the forward direction with some distance, multiplying into +1. And then if we press S, and it's with the forward direction value passed here, will be reaching the same distance, but with multiplication of value -1, because we are pressing S. So basically I'm telling that my character to go backward. So in that way we setting up the you know going forward, backward, right step, and a left step.